Hey everybody, so in this video we're going to start talking about 6.3, which is about rational exponents, and we're going to focus on the first part of the section that does definitions and then talks about exponent rules. Okay, so let's start with the definition. Okay, so this is something that we should remember from the last section, that x to the 1 over n is defined to be the nth root of x. Okay, so now we're going to talk about what about fractional exponents that don't have 1 in the numerator. Okay. So there's two ways that you can think about this. You could think about this as a to the m to the 1 over n. Okay. And this would be equal to, right, here's my base. So that turns into the radicand. Okay. And then my denominator turns into the index. Okay. Or I could think about this as a to the 1 over n to the m power. Okay. So here I know that a to the 1 over n is going to be the nth root of a, okay, to the m power. Okay. Now, as long as these are all defined, okay, these are all equal. Okay. So as long as all of these make sense, then they're all equal to one another, and it doesn't matter what definition you use. Okay? In a practical sense, this one is often easier because taking the nth root of a smaller number is easier than taking it of a really big number. Okay? So often we will use this one just because in a practical sense, if we don't have a calculator, this is a little bit easier to do by hand. Okay? So let's actually see some examples of that. Okay. Okay, so let's write out our two definitions here. Okay, so one would be that this is 25 cubed, okay, and then square root. Okay, don't put the 2 as the index because you don't really need the 25, or you don't really need the 2 as the index, okay? Now to do 25 cubed, I'm really going to need my calculator, right? Okay, so if I do use a calculator, I get this, okay? And then to take the square root of that, I would absolutely need a calculator, right? There's no way that you just know what the square root of this is, okay? So this would give you 125, okay? So I needed a calculator for this step and for this one, okay? Let's look at the other way of doing this, okay? I can think about this as square root of 25 raised to the third power. Okay, now I know the square root of 25 is 5. Okay, 5 cubed is 5 times 5 times 5, so 25 times 5, 125. Okay, so you can see that you absolutely will get the same answer. Here we needed to use a calculator, and here we didn't need to use one. Okay, so if you have a calculator, both of these are fine. But remember, you won't be using a calculator for the exam. So in that case, this is really the way to go. Okay, let's look at another example. Okay, So we're going to do this one two ways. So the first way that we can see this is as the fifth root of 32 squared. Okay. Now, I don't know about you, but I don't know what 32 squared is, so I would have to use a calculator. I guess I could do this one by hand, write 32 times 32 and just do it out by hand. Okay. But I don't know it off the top of my head. Okay. Now, I absolutely would need a calculator to do the fifth root of 1024. Okay, I don't know what that is. Okay, that gives me 4. Okay, so again, this method does give you an answer, and it's the right answer, but I had to use my calculator here. Okay, even if you decided not to use it for this step, which I did, you would definitely need it to get the fifth root of 1024. Okay, now here, I'm going to think about this as the fifth root of 32 and then square it. Okay, so the fifth root of 32 is 2. 2 squared is 4. Okay, so again, you can see you're getting the same answer. You're not getting the wrong answer from this, but this is so much easier to do by hand, right? And the reason is just order of operations. It's easier to take the root first and get something small, and then do the exponent and make it larger. Okay, so let's do a couple more of those just using the method that I think is the easier method without a calculator, okay, which is doing the root first. Okay, so I would rewrite this as the cube root of 27 squared, right? So I'm going to do the root first and then the exponent. You can use these parentheses or you can leave them out. Okay, cube root of 27 is 3. 3 squared is 9. Okay, and the last one of these, 1/4 to the 3 halves. Okay, so this is going to be the square root because the root part comes from the denominator. So the square root of 1/4, okay, to the third power. Now the square root of 1/4 is 1/2, so I'm going to get 1/2 to the third power, which is 1 cubed over 2 cubed, sorry. Okay, 1 over 8. All right. So that's how you evaluate these fractional exponents for numerical values, okay? You can do the power first or you can do the root first, but like I said, I recommend root first, power second, okay? All right. Let's look at an example of the exponent rules with these fractional exponents. Okay, now all of the exponents that we talked about in the previous section that were for whole number exponents also apply to fractional exponents. Okay, so let's look at some examples. Okay, now we know that when we have two of the same base with exponents, right, we're going to add the exponents together. Okay, so we'll have 6/5 plus 4/5. Okay, now in some cases you're going to have to make common denominators. Here we already have common denominators, so we're just going to add these together. Okay, and this is really the only new exponent rule that we're going to talk about. Okay, and here the question is really, is it okay to say that 10 over 5 is the same as 2 if it's in the exponent? Okay, and the answer is that for us, yes, it's okay. Okay. There are certain situations where this and this are different, okay, but we're not going to stress that too much, and we're going to say that yes, we can reduce this exponent, right? 10 divided by 5 is 2, okay, and we're going to reduce those exponents as much as possible. Okay, let's see another example. Okay. Now I'm going to go ahead and add these two exponents first. Remember that you guys are welcome to distribute this exponent first. It's up to you, okay? So I'm going to combine these by adding first, okay? 4/3 plus 1/3 is 5/3, okay? And then I'm going to distribute this exponent to both of these two bases, okay? So I would get 9 squared b to the 5/3 squared, okay? So 9 squared is 81. And when I multiply these exponents, I'm going to get 10 over 3, okay? I don't have to worry about simplifying this one because 10 over 3 doesn't simplify, okay? All right, let's look at another example. Okay, so the first thing I'm going to do here is say that 8 divided by 2 is 4. Okay, and for these w's, I'm going to subtract the exponents. Okay, so 9/4 minus 3/4. Okay, again, in some situations we would need to make common denominators, but here, because I already have common denominators, we can just subtract them. 9 minus 3 is 6/4. Okay, and here we are going to want to reduce our exponent because 6 over 4 is the same as 3 over 2. Okay, all right. One more for this example. Okay, so for this one, we're going to use the same exponent rule, okay, as we did here, which is that when you have a fraction, you can subtract the exponents, okay? Remember that when you don't see an exponent, that means the exponent is 1, okay? So when I subtract my exponents, I'm going to get 3/4 minus 1, okay? Here I do have to make common denominators. Okay, so 3/4 minus 4/4 is minus 1/4. Okay, and remember that when you have a negative exponent, this moves it into the denominator. So my final answer would be 1 over k to the 1/4. Okay. All right. So let's look at some more examples of using exponent rules with these fractional exponents. Okay, so again, we're using all the same exponent rules. Okay, and the only reason it looks more difficult is because the exponents themselves are more complicated. Okay. Okay. So I want to go ahead and do this one first the way that we did the previous example, where we added these first and then multiplied by 2. Okay, so if we're going to do that, we would have a to the 1/3 plus 1/2, okay, squared. Okay. So I'm going to add those two fractions together by making common denominators. Okay, so I would have 2/6 plus 3/6, which is 5/6. Okay. And now I have an exponent raised to another exponent, so I would multiply them together. 5/6 times 2 is 5/3. Okay. All right. Another way to do this, remember these exponent rule questions often have a lot of ways to do them, is to distribute this exponent to both bases first. So this would give us a to the 1/3 squared times a to the 1/2 squared. Okay, so then we're going to multiply these two exponents and these two exponents. So this would give us a to the 2/3 times a to the 1. Okay, and now we're going to add these two together. Okay, so this would give me a to the 5/3. Okay, so same answer, same number of steps, honestly, right? 1, 2, 3. So either way is just as good. Okay. All right. Let's look at one more example like this. Okay. So again, I'm going to show you guys two different methods. So the first method is my personal preference, but the second method is what I see most students do. Again, they're both totally fine. There's no reason to do one over the other. Okay. So the first thing I would do is simplify the numerator by adding these exponents together. Okay, and I'm just going to put this as x to the 1 power because we remember that that's what that means. Okay, so negative 1/4 plus 1/2 is 1/4. Okay, over x to the 1. Okay, and now because I have the same base in the numerator and the denominator, I'm going to subtract the exponents. Okay, so I would have 1/4 minus 1. Okay, so this would give me 5x to the negative 3/4. Okay, and I remember that the negative exponent moves into the denominator. 5 over x to the 3/4. Okay, so that's the method where you simplify the numerator first and then combine the two. Okay. If you prefer to move all of the ones with negative exponents first, this is also a totally acceptable method. Okay, so remember we had 5x to the negative 1/4, x to the 1/2 over x. Okay, so if you decide to move this into the denominator first, you will get 5x to the 1/2 over x to the 1/4 times x. Okay, remember this is x to the 1. Okay, now you can combine these two by adding the exponents together. Okay. Okay, so I'll have 5x to the 1/2 over x to the 5/4. Okay, and now I'll need to subtract my exponents. So I'll get 5x to the 1/2 minus 5/4. Okay, again, you'll have to make common denominators because 1/2 and 5/4 don't have common denominators. Okay, so you'll get 2/4 minus 5/4, which is negative 3/4. Okay, and then you would move this into the denominator. So 5 over x to the 3/4. Okay. So either method, you are getting exactly the same answer. Again, it doesn't matter which method you prefer or what you use. Sorry, little cat. And you guys should do what you are comfortable with. Okay. I just wanted to announce at the end of this video that you are going to have paper homework for this section. Okay, so look out for that on Canvas, and I will see you guys soon.